Welcome to clickmyproject.com. Now let me discuss about fabric defect detection using Bitplane Decomposition and mathematical morphology. This paper presents a new supervised method for detecting the defect in texture image. The abnormality will be identified by the use of morphological operation. Here we localize the defect by the use of dilode, erode and the enclose operation. After that, we are extracting the GLCM feature for the texture image. It is a gray level co-occurrence matrix is image analysis technique. In GLCM, several statistics information are derived using different formulas. These statistics provide the information about the texture of an image, such as energy, entropy, dissimilarity, contrast. These type of feature values will be extracted by the GLCM. After that, we are also computing the DCT feature. DCT is the discrete cosine transform, which transform the image from a spatial domain to frequency domain. And then we computing the standard deviation for the DCT coefficient. This standard deviation is the feature values for the texture image. GLCM and DCT feature is passed to the neural network. Neural network is contain the input layer and hidden layer and output layer. The neural network will contain the different node as neurons. It is used to classify the result. Finally, it will predict about the result. Then after the classification, here we are localize the defect in the texture image. This is the flow of our project. Here we have to provide an input image as a texture image. The texture image is contain the image of textile image that is passed to the feature extraction. In feature extraction, here we are using the two algorithm GLCM and DCT. GLCM is the gray level co-occurrence matrix. In the GLCM, several statistic information are derived using the different formulas. These statistics provide the information about the texture of an image, such as energy, entropy, dissimilarity, contrast. These type of feature values will be extracted by the use of GLCM. After extracting feature, here we are also extracting the DCT. DCT is the discrete cosine transform, which is used to convert the image from spatial domain to frequency domain. And also we are computing the standard deviation for DCT coefficient. These feature values will be passed to the feature vector. In feature vector, here we are combining these two feature values as a single feature vector. The single feature vector will pass to the neural network classification. Neural network classification, it contains the three layer, that is the input layer, hidden layer and the output layer, and it is also have a neurons as a node. These nodes is used to classify about the feature, and finally it will predict about the result. The result is passed to the defect detection. In defect detection, we are localize the defect by the use of morphological operation by such as dilode, erode and enclose operation, and the defect output will be displayed in the image. Now let's see the execution part. Here I am having one main.temp file. This is the main file. Select this file, right click, run the file. This is our guide design. Here we have to provide our texture image as input. In dataset, totally I am having 100 image. First 50 is the defect texture image and the second 50 is the normal texture image. Now I am providing the defect image as the input. The provided input image is displayed in the axis. Here we are extracting the GLCM feature. GLCM is gray level co-occurrence matrix, which is used to derive the statistical information about the images such as energy, entropy, correlation, dissimilarity, and these type of feature values will be extracted by the use of GLCM. And we are also extracting the DCT feature. These type of features will be displayed in the first table. These feature values will pass through the classification. In classification, here we are using the neural network classifier. It contains the input layer, hidden layer and the output layer, which is used to predict about the result. It is a supervised classifier. Now let's see the result of this neural network. Here we are having the result as defect image. If the image is defect means it will, here we are localize the defect. For localizing the defect, here we are using the morphology operation, diaload arrow, and the include open operation. Now let's see the result of localization. Here we are localize the defect place in the original image. This is the diaload operation. This is the Bitplane operation. This is the Bitplane operation. Here whole dataset analysis will be done here. Here we extract the feature for the whole database dataset images. These are the feature values of whole dataset. Here we are analyze about the classifier. If there is any misclassification means this confusion matrix values will be reduced. Here we are having the result as 100%, so our classifier don't have any misclassification. This is the performance graph for the trained classifier that is plotted in figure. Here we are showing to detect defect in texture image and the localization of the texture image. Thank you.